Team, we're now ready for section 2.2, differentiating products and quotients. So let's first talk about the product rule. If you have basically two functions being multiplied, here's the derivative. If you think of it as keeping them in the same order, we can take the derivative of the first function times the second, plus the first function times the derivative of the second. So be sure that you have that addition in between. So for example, if we have y equals 3x to the fourth times the quantity 2x squared minus 9x plus 1, we have two functions here. We have a monomial being multiplied by a trinomial. So we can consider this like the f function and the g function. So when we try to find the derivative, we're going to take the derivative of the first part, the 3x to the fourth. So we multiply by the exponent. We would get a 12x and then subtract 1 from the exponent, get a 3. And then we keep the next one just the same as it is, 2x squared minus 9x plus 1. We don't change anything. Then we flip it around. We keep the first function exactly the same as originally, set 3x to the fourth. And then we take the derivative of the second function. So again, multiplying by the exponent, we would get 4x to the first minus 9. And remember, 1, the derivative of any constant is going to be 0. So here you've already taken the derivative. Just so you can see it, that's the derivative of the first times the second as it is, plus the first as is times the derivative of the second. So the only thing you need to do next is distribute and combine any like terms, just clean it up. So we'd get y prime equals 24x to the fifth minus, let's see, is that 108? 12 times 9, x to the fourth plus 12x cubed. And then we distribute in the second one there, we get 12x to the fifth minus 27x to the fourth. So everybody double check my algebra and arithmetic there. And let's combine any like terms that we have. We have a couple of fifth exponents there. So we get 24 and 12. What is that? 36x to the fifth. Negative 128x to the fourth minus 27x to the fourth. If we combine those, let's see, I think it gives us 135x to the fourth. And then last we have a positive 12x cubed. Okay. So don't forget, when you have two functions being multiplied within a function, you see that things are being multiplied, you've got derivative of the first times the second plus the first times the derivative of the second. Here's a second example. F of x equals, we have in parentheses, 2 square root of x plus 4x minus 3. So we can consider that our first function, times the binomial 5x minus 4. Consider that our second function. And we want to be able to find the first derivative. So f prime, we are going to take the derivative of the first, but remember when we have the radicals, it's nice to write those as a power, x to the 1/2, so we can use that power derivative rule. So here we can multiply the 1/2 times the 2. So that gives us a 1x to the negative 1/2. 4 times x, the derivative there would just be 4. And then the derivative of the negative 3 would be 0 times the second function as is. That's the part that most people forget. And then let's do it again, but take the derivative of the second one instead. So we're going to keep the first one again. 2, and we can go ahead and write it x to the 1/2 in case we multiply or simplify here in a minute, plus 4x minus 3 times the derivative of the second factor, which would be 5. Because remember, the derivative of a constant 4 would just be 0. So again, we've taken the derivative of the first function times the derivative of the second one as is, plus first function as is, times the derivative of the second function. I wrote it correctly. I hope I said it correctly. So now all we need to do is distribute, simplify, see how it goes. So x to the negative 1/2 times 5 to the x, that would give us 5x. We add the exponent, so that would give us a positive 1/2. Now we distribute it to the negative 4. So we get a negative 4x to the negative 1/2 plus 20x minus 16. So we've distributed the first two. Now let's distribute this 5 over here, and that's going to give us plus 10x to the positive 1/2 plus 20x minus 15. So let's combine any like terms that we have. Let's see, we have a 5x to the 1/2 and a 10x to the 1/2. So that would give us 15x to the 1/2, but remember x to the 1/2 is square root. So we get 15 square root of x. We only have 1x to the negative 1/2. So that gives us a negative 4. Remember, a negative exponent gives it the reciprocal, so it changes position. So it's going to go down below as the square root of x. We have two 20x's, so that would give us plus 40x. And then a negative 16 minus a negative 15 is a negative 31. Now, as far as I'm concerned, this is fine, but they may want you to rationalize that denominator. In other words, get rid of this radical in the bottom. So we can multiply bottom and top by the square root of x. So that would give us 15 square root of x minus 4 square root of x over x plus 40x minus 31. Nothing else combines there. We're not solving. We can't get rid of the denominator. Now, the second rule we want to look at is called the quotient rule, because that's when we're dividing. So if you have a function being divided by a function, here's what it's going to look like. The top is going to look just like the product, except for it's going to be subtraction instead of addition. And then on the bottom, you're going to have g squared. How some people write it is the low, okay, so you got the low function times the derivative of the high function minus the high function times the derivative of the low function over low times low. That's where this little sing-songy thingy comes in. Low d high minus high d low over low over low. So yeah, I know it's lame. So it is the low times the derivative of the high minus the high function times the derivative of the low function over low over low. Whatever helps. Some people like thinking it as the product rule that you already know or will know. The product rule, but with a minus, because it's, think of it like exponent rules. When you divide, you subtract exponents. So subtraction will go with the division part. Just remember to square the bottom. And you're not taking the derivative of that bottom function in the bottom. You're just squaring it as is. So let's do an example. This one might take a while. Be sure you put it kind of on a note card and take a look at it every once in a while. So in example C, if we're trying to find the derivative, we're going to take the low function, the 2x plus 5, times the derivative of the upper function, the high function. That would be a 6x plus 9 minus the upper function, as is, 3x squared plus 9x minus 1, times the derivative of the lower function, which would just be 2. If you're not sure, again, where I'm getting these derivatives, go back to the derivatives of power terms, polynomials, and things like that. And then in the bottom, we take 2x plus 5 and we square it. A lot of people want to reduce. They see those 2x plus 5s, one on top, one on bottom. We cannot reduce it, remember, because we have subtraction here. Everything has to be in multiplication or division in order to divide out. As long as we have that minus sign in there, we can't do it. So all we can do now, you've already technically taken the derivative, is we have to clean it up. You always want your answer in simplified form. So this is the hard part for most people, is just all the algebra. So if we FOIL these two here first, that will give us a 12x squared plus 18x plus 30x plus 45. Okay, so there's the first guy. Minus, and then we want to distribute the 2 into that trinomial, but we have to be careful because, again, you're subtracting whatever that product's going to be. And so we're going to have to distribute that negative later. So we distribute that 2, we can get a 6x squared plus 18x minus 2 over, I would go ahead and just leave this factor. There's no, otherwise you may be tempted to reduce something that you cannot reduce. So I just leave it as being squared. So now let's distribute this negative. This becomes, and I can do it maybe here, this becomes then a negative 6x. This becomes a negative 18x, and that becomes a positive 2. Okay, so we got to change their signs. Now we can combine any like terms on top. We have a 12x squared and a negative 6x squared. So that gives us a positive 6x squared. 18x plus 30x. Well, actually, we can look here. This 18x is positive, but this 18x became negative when we distributed that negative. So we're just left with a plus 30x. And then a positive 45 plus 2 gives us plus 47 all over 2x plus 5 quantity squared. And at first I thought the top might have a GCF, but 6 goes into 30, but it doesn't go into 47. All right, and we could try to factor the top, but even if we multiplied 6 times 47, they're both positive. There's no factors there that are going to add up to a 30. I mean, 47 is larger than 30, and so they're just going to keep getting bigger. So that's as simple as we got. In example D, we have a quotient again, so we want to find the derivative. So we take the bottom function as is, low, D high, so the derivative of the top function, which would be a 12x squared minus 2, minus the top function as is, times the derivative of the bottom function, which would just be 5, all over the bottom function squared. So again, it's like a template. Low D high minus high D low, over low, over low. Now it's just some algebra to clean it up. If we distribute the first 2, that would give us a 60x cubed minus 10x plus 12x squared minus 2. Okay, so that's the first guy. Now, something that you can do because it's subtraction and you're subtracting whatever this product is, you could change this to a positive, but then change the sign of one of those factors. So I can change it to a negative 4x cubed plus 2x, or I can change that 5 to a negative 5. So in other words, you're multiplying by that negative first, then distributing, but you only multiply it to one of them. I chose the smaller one. So now we can distribute that negative 5. So that's going to give us a negative 20x cubed plus 10x. And then we combine all of our, almost forgot about my denominator. 5x plus 1 squared. So now when we combine like terms, we got 2x cubes. So that will give us a 40x cubed, a 12x squared. He's by himself. This negative 10x and that positive 10x add up to 0. And then we just have a negative 2 over 5x plus 1 quantity squared. Now the top does have a GCF of 2, but we have an x cubed and then an x squared. So it doesn't look like it's going to factor in a way that would reduce anything from the denominator. So we could stop right there. So now we're looking at tangent line equations again. Don't forget if we have, some curve here at, let's say x equals a, the tangent line follows along, kind of snuggles up to the curve, and we can find the slope at a single point. So the function f of x and its tangent line at x equals a always have the same point at x equals a. So in other words, both of them will have the point a, and f at a. Also, the derivative at x equals a is going to be the slope of that tangent line, because that's the definition, which means we can find the slope at that point, and we have a point on that tangent line, and that's all we need to do to come up with an equation of a line. Remember, we have y equals mx plus b, or y minus y1 equals the slope times x minus x1. To find either of these formats, we only need the slope and a point. So let's do that. So in example E, we're to find the equation of the tangent line of the function f of x equals the quantity 2x cubed minus 4x times the quantity 5x plus 7 at x equals 1. Well, let's go ahead and find the point, which means we have to find the function value at 1. So we're going to plug in 1 for all of our x's. We have 2 times 1 cubed minus 4 times 1 times 5 times 1 plus 7. Again, that's plugging in 1 into all of those x's. Using our order of operations, 1 cubed is just 1. So we get 2 minus 4 times 5 plus 7, which is a negative 2 times 12, if I did that correctly. Negative 24. So that means we have the point 1, negative 24 on the graph of f of x, but that point is also shared with the tangent line at x equals 1. Okay, so we have a point on the line. Now we need to find the slope at x equals 1, and that's our hint to take the derivative. So we're going to do the first derivative. We have two items being multiplied, two binomials, so we have to use the product rule. So we're going to take the derivative of the first, so that's 6x squared minus 4, times the second as is, 5x plus 7, plus the first as is, 2x cubed minus 4x, times the derivative of the second, which is just 5. We distribute, so we'll get 30x cubed plus 42x squared minus 20x minus 28, question mark. All of a sudden I've forgotten all my multiplication rules. So we just FOILed or distributed the two binomials, plus now we're going to distribute the 5, and we'll get 10x cubed minus 20x. Let's clean this up. 30x cubed and 10x cubed, so we get a 40x cubed. We only have one x squared, so we get a 42x squared. Negative 20x minus 20x is a negative 40x, and a minus 28. So that is a simplified version of the first derivative. So we've got that function, but we want the derivative or the slope at a particular point. So we're going to find the first derivative where x equals 1. So we have 40 times 1 cubed plus 42 times 1 squared minus 40 times 1 minus 28. So that gives us 40 plus 42 minus 40 minus 28, which will give us a 14. So that's our slope. So that's our m. So we have m is 14, and we have a point on the tangent line. So now it's back to Algebra 1, coming up with an equation. And again, it's up to you guys which version you want to do. But let's say we did y minus y1 equals the slope times x minus x1. Then we would get y minus a negative 24, because here's our y1 up here, equals our slope of 14 times x minus, and here's our x1, which is 1. So remember, minus a negative, we have to pay attention to those signs. So we get y plus 24 equals 14x minus 14. Subtract 24 from both sides, we get 14x minus 38. So there's the tangent line of that particular function at x equals 1. Now, if you're wanting to do the y equals mx plus b, which is the version that most people remember, We can plug in the slope, which is 14, but notice the point we have is not the y-intercept. We can tell because the x is not 0, but we can plug in that point for our x and our y value, and then solve for the b. So we get a negative 24 equals 14 plus b. Subtract 24 from both sides, we get a negative 38 as our b value. Now we can plug it back in. Slope was 14, b value was a negative 38. Notice we get the same thing, okay? So this is an or, you don't have to do it twice. All right, that's it for this section. Good luck. If you have any questions, let us know. Bye.